For the last 50 years or so, a single really powerful story has shaped how we think about life. But what if that story, the one a lot of us grew up with, has it completely backward? Okay, let's dive in. We're going to explore a pretty profound challenge to one of modern biology's most foundational ideas.
This is the idea that pretty much everyone knows, right? Richard Dawkins' amazing metaphor from The Selfish Gene. It paints this picture of us as, gigantic lumbering robots, built by our genes for our genes. It's this idea that life is built from the bottom up. DNA is king. But what if that's not the whole story? What if the exact opposite is also true?
And this is where it gets really wild. The physiologist Dennis Noble takes that famous statement from Dawkins and just flips it completely on its head. Noble's take is that genes aren't the masters at all. In fact, he says they're the prisoners, and they are totally dependent on us, the organism. That's not just a tweak to the theory. That's a whole different reality.
Okay, so to really get what Noble is saying, we first have to appreciate just how powerful the idea he's challenging really is. This gene's eye view basically says that evolution and life itself is driven from the bottom up. The genes are the real players, the replicators, and we're just the vehicles they built to ferry themselves into the next generation. And the absolute core of this idea is that information only flows one way. It's like a one-way street. DNA makes RNA, and RNA makes protein. The information goes out from the genome to build the organism. But the key thing is, nothing that you do, nothing in your environment, is supposed to be able to talk back to the DNA and change that fundamental code. This has been a central pillar of biology for decades. So, you might be asking, who is this guy trying to upend everything? And look, this isn't some philosopher just poking around in biology. Dennis Noble is an absolute giant in his own field, and his entire perspective comes from a lifetime of studying not just the little parts of life, but how they all work together as a whole system. And this timeline, wow, it really shows you he's the real deal. Think about it. Way back in 1960, he built the very first computer model of a beating heart. That was revolutionary. It led to him becoming a fellow of the Royal Society, holding a top job at Oxford. He didn't just contribute to a field, he basically helped create a whole new one called systems biology. So yeah, to say his scientific credit is solid would be a massive understatement. And this is so key to understanding where he's coming from. Think about it. You can't figure out how a heart beats by just staring at one tiny little protein or a single ion channel. You have to see how all the parts interact, how the system as a whole creates that rhythm. This guy was thinking in terms of whole systems from day one. Okay, so how does this way of thinking about the heart scale up to, all of life? Basically, his work on the heart led him to this radically different view of biology, where things don't just happen from the bottom up. He argues causation also flows from the top down. So what is systems biology? Well, in a nutshell, it says the magic of life isn't in the individual molecules themselves. It's in the dance, the incredibly complex network of interactions between them. Function emerges from that network. It's about studying the whole orchestra, not just the first violin. And from this viewpoint, Noble came up with what he calls the principles of biological relativity. And let me tell you, they are radical. So, no privilege level? That just means the gene isn't the big boss. Not a one-way street means the organism can actually influence the genome. And DNA not being the only way to pass things on? That opens the door to stuff like epigenetics, where your experiences can literally change how your genes are used. It completely flips our idea of cause and effect on its head.
All right, take a look at this diagram from Noble's work, because it's super important. See, the old way of thinking is that everything flows up from the molecules. But Noble talks about downward causation. This means the higher levels, an animal's behavior, its social group, the whole environment, they set the rules of the game for the lower levels. They shape and direct how all those molecules and genes are going to behave. So in a way, the whole system actually gives meaning to its tiny parts.
Okay, let's just stop and think about what this really means. Let's be crystal clear. If causation flows both ways, it means that the way an organism lives, the environment it chooses, the challenges it faces, all of these higher-level things can send signals all the way down that influence how the genome is used, read, and maybe even restructured. This all leads to a huge, huge question. If we're not just robots running a genetic program, then where does choice come from? Where does creativity or agency come from? Well, Noble has a really fascinating idea. And this is basically the age-old problem of free will, but for biologists, right? If we're all just physical stuff, atoms bouncing around according to the laws of physics, How can a chimpanzee genuinely choose the right stone to crack a nut? How can any action be anything other than just a predetermined result?
Well, Noble's answer is this idea he calls harnessing stochasticity. Now, that's a mouthful, I know, but the idea behind it is just beautiful. Stochasticity, it's just a fancy word for randomness. The idea is that life doesn't fight against the randomness that's just inherent in molecules. It actually uses that randomness. It treats chance as a creative tool.
So here's kind of how it might work in practice. Let's say an animal faces a problem. It doesn't just calculate one single perfect answer. Instead, all this randomness down at the cellular level throws up a bunch of different possible solutions, like a menu of options. And then the organism, as a whole system, looks at that menu, assesses the options, and makes a choice to solve the puzzle. It's a way for real, non-predetermined choice to emerge from a purely physical system.
Okay, so now let's take all of this, top-down control, choice, harnessing randomness, and apply it to the biggest idea in biology, evolution. If organisms have real agency and can make purposeful choices, that has to have massive implications for how species change over time.
And yeah, it does. Noble is one of the main people behind something called the third way of evolution. This idea says evolution isn't just about random mutations and natural selection. It argues that the purposeful actions of organisms, like a beaver building a dam, actively shape their own evolution. The argument is that these choices are a major creative force, helping to direct where evolution goes next.
Okay, now full stop. We have to be super clear about something here. This third way idea, it is absolutely not the mainstream scientific consensus. It's seen as a fringe movement that pushes back against some core ideas of modern evolutionary theory. So we're talking about it as a really interesting and powerful challenge, but it's not the textbook answer you'll get in most biology classes.
And that kind of brings us full circle, right back to the beginning. The fascinating thing is, this isn't just a fight over data. It's about the very stories, the metaphors we use to understand ourselves. So, who's the star of the show? Is it the gene, and we're just its survival machine? Or are we the stars, and the genes are the tools we use to navigate the world?
When you strip it all away, this whole debate really pushes us to ask the biggest question there is. If we let go of these simple but maybe limiting metaphors, the blueprint, the machine, we're left with a puzzle that's so much deeper and honestly, so much more interesting. It challenges us to see the living world not as a simple code to be cracked, but as an active, creative process that we're only just beginning to understand.